So today we're going to find volumes using the washer method. Washer. Okay, and I'm going to draw a shape. Don't try to draw this because it's not going to be a very good drawing. All right. So yesterday we learned. Oh, I need to make that smaller. See, I've already messed it up. Yesterday we learned how to find volumes of shapes formed by revolving something about an axis. So pretend that like there's our axis. Okay? So we have like a funky vase kind of a thing, right? So pretend this is our shape, and if this was totally solid, then we would use disk method to find the volume. But suppose instead there is space carved out of the inside. That looks like that.
Okay.
Okay, so now what we have is this vessel, and you have to visualize in 3 dimensions, right, what this looks like. So we've got this, where it's got stuff making up the sides, but then it has this hollowed out, kind of tapered in cylinder shape on the inside. And that is washer. Yes.
Oh, it is?
Yes. Okay, so what we're going to do, what washer method is if you want to find the amount of materials it takes to make the solid part of the shape, all you do is you do 2 disk methods and subtract, right? So we do a disk method, so we cut the outer shape into cylinders, right? So we cut the outer shape into cylinders, we add all those cylinders together, and we cut the inner shape into cylinders.
You should be an art teacher.
Right, oh, that's just should be dotted. We cut the inner shape into, see, and now it's gone downhill. So anyway, we cut the inner shape into cylinders. So we do a disk method on the outer shape and subtract a disk method on the inner shape, and what's left is the stuff. Okay? So washer method is really just disk minus disk, but we combine it into one integral so that it's a little bit easier and shorter. Okay. By the way, do you guys know why it's called washer method?
It looks like a washer.
Because a
It looks
washer
like
has a
a
hole.
washer. Yes, a washer is a disc with a hole in it.
Looks like a donut, except flat.
They should
Except
have called
it's
it.
flat.
They should have called it donut.
And I actually have a fairly decent example. So, if a disc is a coin, like a quarter, right? That would be a disc, nice flat, it's a cylinder, but it's kind of flat. Then I have this coin right here, right, that has a hole in the center,
Washer. Why do you have so many keys?
right? Then that would be a washer, right? It's like a disc with a hole in the center.
Why do you have so many keys? You have like 3 car keys on there.
Well, no, I just have two car keys,
But
right?
what are all
And
the
a
Car,
key fob.
car, right, because we have 2 cars in our family.
And a key fob.
House, we have 2 different keys for the house, that's not uncommon.
But then what's like the
right?
90 keys down there?
These are all of these are school, all of these,
Oh, 'cause
right?
you're the book person?
So elevator, because you have to have an elevator key now. Do you guys know that?
No?
Yeah?
Wait, that's new.
Yeah, they
I
just
was
required
trying
that,
to use it.
right? My room, that cabinet, small gym key, all of the book rooms in the school, the big giant book room that's down in the gym, and my desk, right?
So question, what happens if you like break your leg and you have to use the elevator then? You have to like just have keys.
You have to get a key. You have to get a key. So you have to have an actual medical reason to get a key.
I just walk into the school with crutches and like.
Yeah, like what if I'm
Miss Price,
like, what if I'm working for books for you and I have that
I have
giant
crutches
thing?
in my
Then
car.
I will
gotta
loan
get
you the
everything.
elevator key.
What if you have 2 people?
They're actually-
You know what we're probably going to do this year for books is,
Stairs?
no, I'll either see if I can get a collection of keys or I'll have someone standing there by the elevator whose only job is to open the elevator for me.
Would that be my job?
Right.
You
Okay,
just take the
so
key
here we
and wax it
go.
and have them duplicate it.
Volumes of revolution, washer method. Here's your formula. It's really just 2 disk methods subtracted. Pi big R squared minus pi little r squared. All right? So there's 2 really common mistakes. One of the most common mistakes is people doing pi and then big R minus little r and squaring the whole thing. Not the same. Alright?
Yeah, they didn't take the integral.
Okay, well, okay, so you can't just subtract the radii and square that the answer. You have to do big R squared minus little r squared. Alright? Now, big R is the radius of the outer shape. Alright? And the way that you find big R, why don't we put all the cell phones away?
Mustafa.
Okay. Alright. The way you find big R is it's always going to consist of the axis of revolution and what I call the outer function or the outer boundary. The outer boundary, yes. So outer function or outer boundary. Always top minus bottom or right minus left if it's dy. Okay? Little r is going to consist of the axis of revolution and the inner boundary. Always top minus bottom or right minus left. So you can't write a formula for big R. You can't say it's axis minus boundary or boundary minus axis because you don't know which one's going to be on top. So each problem is different. All right, but there's your basic setup. We're going to do 4 examples. And they're all going to be very similar. They're all going to use the exact same beginning. Find the volume of the solid created by revolving the region enclosed by y equals x squared plus 1 and y equals 2 about the x-axis. So y equals x squared plus 1 and y equals 2 about the x-axis. Does everyone have this stuff written down? Because I'm going to erase some of this. Just to give myself some space.
This will be my last math you did ever.
What about college?
I have to take high school math.
I hope you do.
Not math.
Okay, everyone have it down?
I hope Mustafa, you're not.
I'm going to walk you through the first, and then I'm going to give you guys several more to do without help. Alright, but first let's just graph what's going on. X squared plus 1 is a parabola shifted up 1. So x squared plus 1 looks like that.
Oh, it's just gonna be a smaller one. Oh no, it's not.
Y equals 2 is what kind of a line?
Horizontal.
Mustafa, stay with me. Okay, so horizontal line through 2.
Jenna's being rude.
So this is the region that's enclosed by those 2 graphs. We are revolving this about the x-axis. Alright? If you revolve this region about the x-axis, and you don't have to know this, it's okay if you can't visualize, but does anyone know what kind of a shape it's going to be?
It's like a donut with like a flat side, kind of.
Yeah, it's like a donut where the outsides are flat. I like to think of it as a tire. Because if you think of a car tire, the outsides are fairly flat, and then the insides have that curved shape to fit into the wheel, right?
Yeah.
Alright, so anyway, so that's the shape you're going to get. And here's what I want you to do. First thing we do for disk method is we're going to find, or for washer method, is we're going to find big R and little r. And I have a technique that always works, because this can get confusing when the problems get harder. Here's what I want you to do. When you have to find big R and little r, I want you to start on the axis of revolution, wherever it happens to be. In this case, it's the x-axis. So we're going to start on the axis of revolution. It doesn't matter where, left or right, just somewhere on there. Put a dot. And then draw to the farthest away boundary that you hit. That's big R. Now you have to figure out the top and the bottom. And I'm going to go ahead and label these functions. So this top function, this is y equals 2. The bottom function is y equals x squared plus 1. And this, of course, is the x-axis. So what's big R?
Y equals 2.
It's 2 minus 0, or 2. Top is 2, bottom is y equals 0, 2 minus 0 is 2.
What happens if it's all like curved?
Well, let's do little r.
Oh
Little r, you again start at the axis. Always start at the axis. So you start at the axis, doesn't matter where, and you draw to the nearer boundary, right? That would be little r.
But what if you drew it like farther to the right? Wouldn't that be a higher boundary?
Is this function different?
No. But isn't R like a number?
No,
No, it's the function in
it's
that
the
case.
function.
Just two.
Ah, see?
Got me, because 2 is a number, so.
Ah, yep, okay. So anyway, little r, what's the top for little r?
X squared minus.
X
Or
squared
plus
plus 1 minus and then 0. Your axis has to be in both of them. Alright? The axis of revolution will always be in both big R and little r, somewhere. So, well, for this problem it's 0. For the next problem it won't be. Okay, so now we set up our volume. Volume equals pi integral. I want you to use kind of a template. Something squared minus something squared. By the way, is this a dx or a dy?
Yeah.
How do you know it's dx? Not just because it's the x-axis, but because the axis of revolution is
About the x-axis.
is
Horizontal.
horizontal, right? Very good. All right, so then all we do is we put big R in here, little r in here. We need the limits. Uh-oh, they didn't give us any limits. Ah, okay. So we gotta find these points of intersection, right? Okay, so we set x squared plus 1 equal to 2. So x squared equals 1, and what's x?
Plus or minus 1.
Plus or minus 1. So we're going negative 1 to 1. Make sure that all showed up. Yeah.
Is it 13.40?
No, I don't know. Is that equal to 64/15 times 5?
I don't know.
That's the answer I have.
64%.
Okay, any questions on this? We're gonna change it. Your next example, rather than rewriting the whole thing again, I want you to just write ditto.
Yeah, it is. Hashtag gotcha.
Wait, Nelson, what's the answer?
13.4041. I have it.
13.4.
We're going to do the exact same problem, but we're gonna revolve about the line y equals negative 1.
I will I hope that gets on camera. I'm just kidding, Vita. I love
So the shape is the same, everything's the same. The only difference is that our axis of revolution is now down there. Everyone take a minute. I want you to see if you can find big R and little r and set up your integral. Feel free to talk.
Alright, guys.
New stuff.
Talking is good.
Would it be three?
Talk to each other. Compare your answers. Make sure you guys match.
If you get 2 and I get a plus 2. Yeah.
Do you just fart?
Oh.
No.
I was just wondering. One time I farted in a movie theater when it was like a quiet scene. It was like the most awkward thing ever because it was like one of those loud farts, like, you know, like. Oh my god! It was like one of those. It was like the quiet scene where they're like tiptoeing around in the movie theater. I was just like, awkward. I just kind of like, I switched seats. I like got up and like went to a different seat. Yeah, I was trying to get away from the smell. It was incredibly awkward. I'm not gonna lie.
So anyway,
I have no idea.
here we go. Big R, go from the axis to the farther away boundary. That's big R. Little r, you go from the axis to the closer boundary. That's little r. Alright? So for big R equals what minus what?
2 minus -1.
2 minus -1. So big R is going to be 3. Little r is what minus what?
X squared plus 1 minus -1.
X squared plus 1 minus -1. So little r is x squared plus 2. Does that make sense? Good. So our volume is pi integral. Did the limits change?
No.
No, still -1 to 1 of big R squared minus little r squared dx.
21.78.
88 pi divided by 5.
Good. I don't have this one.
Oh, wait, yeah, I see what it is.
Alright, any questions on this one? Y'all feel
Wait,
comfortable?
are you sure? 88.
I got,
No, it's gonna say 55 point something.
I don't think that's right. I got 21.78.
when I do, oh, I got 104/15
I got
pi.
55.29 and converted to pi divided by 5.
The correct answer is 104/15 times pi. See if that matches what you got.
Yeah, that matches what I got.
Okay.
Sorry, Ron.
Alright, we're gonna take it up a notch.
Yeah, no.
But what'd you get?
The correct answer is 104/15 times pi.
So it's 104/15?
104
It's
over
like
15
21.78.
times pi.
Oh, but that's
21.78,
not
right?
the y, not the x.
Ah.
Okay, I know I did that.
Nelson, you get
Okay.
21.71?
Probably. I mean, I got something with 21 and
Alright,
whatever that is.
ditto. Now we're going about the line y equals 5.
I just want to switch. Oh my goodness.
Yeah. Hold up. What's that? I want to be a dad.
So we're going, our axis is now up here. Everything else is the same, but the axis is up here. I want everyone to find big R, little r.
Big R, switch.
Whoa.
Careful, guys. Careful.
Top minus bottom, top minus bottom. Find big R, little r, and set up your integral.
But also the outer boundary is now different too.
Yep,
Oh
yep.
snap. You just messed me up so bad. Good thing I can just scribble out with my pen.
Cool. I got it. Because it's basically just like below it. Yeah. No.
Negative x squared would be 2.
It'll be 2 minus.
No, these are the r and the little. Yeah, but see, it's switched because it used to be down there.
Negative x squared plus 4.
And then also now the inner and outer right, it should be 5 minus.
And you got 3 for big R.
Remember when you are finding big R and little r, you start at the axis. This is our axis. So we're starting up at 5 and drawing to the farther away boundary. That's big R. So for this problem, big R would be 5 minus the quantity x squared plus 1.
It's not top minus bottom?
It is top minus bottom.
Oh, okay.
Oh, I got big R and little R.
Okay? Guys, you always start, this is why I'm telling you, when you are trying to figure out big R, draw a line, start at the axis. Always start at the axis, and then go to the farther away boundary. That's big R.
I just figured it's basically being like upside down and the 5 being the x-axis.
Okay. So anyway, it's 5 minus the quantity x squared plus 1. Which if you want to do 4 minus x squared, that's fine. Okay, what would little r be? Let me draw a picture. There's little r. 5 minus 2. So little r is 3. Does that make sense? That's real important. We still have another notch to go up, but let's set this one up first. Did the limits change?
No.
-1 to 1 of big R squared minus little r squared dx.
What did you get for your answer?
28.484.
I got 61.
I do not have this one.
941.
Because I threw down y equals 5 and on my paper I did y equals 4.
61.9941.
No, that's not what I got.
I think.
Do you want me to do it real quick?
Yeah.
Sure.
Alright.
Hold on.
I think I'm
Alright.
Alright.
No, I plugged it in right.
Hey guys, while I'm figuring out this problem, the rest of you can write ditto and let's see if I can freak you out.
Oh yeah, I might have done it wrong.
Let's go about the line x equals, I'm going to do 7, just to make it really wacky. I haven't done this one yet.
What did you get? 28.
Alright,
28.4.
Yeah, I got it. Never mind.
you got it?
Yeah, I messed up the negative. I did -4 instead of +4.
Hey, what kind of a line is x equals 7?
Yeah,
There's a vertical line.
Oh no, it's a vertical line. How does that change things?
Right minus positive.
Plug
We're
it
going to
in.
go dy,
Y.
which changes everything, except of course, the graph of the region itself does not change, right? It's still a parabola, still bounded by that line, y equals 2. So this is still y equals 2, this is still y equals x squared plus 1. But now we are revolving about that line over there.
It's right minus.
This is going to be a right minus left, and I'm going to walk you through this one.
So it's no longer
Right?
like higher.
So it's no longer like, it's not at all. It's like a bagel,
Yeah.
right?
It's like one. The
Like
bottom
one
half of
at the
bagel.
bottom half of the bagel.
With like
Yeah.
a really large inner circle.
Yeah, yeah.
So.
Okay.
Whoa.
Yeah, it's
So-
like a very small bagel. It's like very disgusting. It's like something bagel boys would make.
Bagel boy is not bad.
Einstein bagels is
So
by far the best
anyway-
bagel company.
Yeah,
we all know
it's
that.
a 6-cheese bagel.
Yeah, we all know that in our hearts of hearts.
Okay.
Don't lie to yourself.
So,
That's just-
pay attention to big R and little r. So big R, we start at the axis, we go to the farthest away boundary, that's right here, that's big R. Little r, we start at the axis and we go to the nearer boundary. Whoa, why, they're the same function.
Split it into 2 functions.
Except, are they the same function?
Not
Because
necessarily.
since this is dy, we need to do what?
Convert it.
We need to solve this for x, right? So if we solve y equals x squared plus 1 for x, so we get x squared is y minus 1, x is plus or minus the square root of y minus 1. How do we pick? Well, if you think about it, the x values are positive on the right side of the y-axis, so this would be x equals the positive root y minus 1, and this side would be x equals the negative root y minus 1.
How come you can't say that, like, can't draw a line to the tip? Or like where it intersects.
You can, it's still gonna be the same, still the same function.
Then why would it y equals 2 go with c?
Because that would make it that would be saying that the radius is constant all the way through, and it's not, right? Okay, so right minus left, what would big R be?
Negative
7 minus negative root y minus 1. Okay? What would little r be?
7 minus root y minus.
Root y minus y, blah blah blah, y minus 1. Don't forget your axis is always in both radii. Always in both. Okay? Alright, so our volume is pi integral 7 plus root y minus 1 squared minus 7 minus root y minus 1 squared dy.
Oh, I
So,
get it now.
are the limits still negative 1 to 1?
No.
No, because the limits have to be y values. So what would the limits be? We need 1 to 2. 1 to 2. This is x equals 1 because it's x squared plus 1, right? Shifted to one place. And then this is 2 because it's bounded by y equals 2.
So it's sort of like you're getting the inner bagels thing and the outer.
And the outer, exactly. Exactly.
I don't know why I took so.
Alright, good. Any questions on that? Alright, so tonight's homework